I'm just going to briefly run through some of the inference rules that we have in our system here. And I might just make a comment or two about how they are applied. If you want a more detailed look at the sort of strategies and moves you can make in applying the rules, then you can take a look at the chapter in the book. It has a number of different strategies. And maybe we'll come back to that if we do some examples. But let's start just by doing sort of a tour of the rules. We already looked at the rule modus ponens, which tells you when you have a premise P implies Q, and then you have a second premise that says P, you get to conclude Q. The next rule in our system also has one of these pretty crazy sort of Latin name. It's called modus tollens. And maybe you remember modus ponens, English name was affirming the antecedent. Modus tollens could be called denying the consequent. It starts off the same way that modus ponens starts off. You have a premise that tells you P implies Q. The second premise this time is not Q, the denial of the consequent of the conditional. So if P implies Q and then Q is not true, you can conclude P is not true. We could do a table, but hopefully this makes sense to you that, if Q isn't true and P implies Q, well then how could P be true? Q would be true if it was. So that's the idea behind that. And just like modus ponens, this works for any sentences that you put in for P and Q, any sentences whatsoever. The next rule in our system is disjunctive syllogism. And it's called disjunctive because it starts with a disjunction, remember, an or statement. So the premise is P or Q. And then we have another premise that tells us not P. So this is what you may have heard called process of elimination. It's a fundamental logical principle. If it's definitely down to P or Q, one of two alternatives, and then we rule out P, that means we get to conclude that it's got to be Q. So pretty straightforward principle there. Our next rule gets maybe a tiny bit more sophisticated than the last three, which were pretty commonsensical. It's called hypothetical syllogism. A hypothetical syllogism is where we have a premise that says P implies Q, and then another premise that tells us Q implies R, some third thing. Then we conclude, since P implies Q and Q implies R, that P implies R. So there are different ways to sort of look at this rule. I think of it as sort of chaining together these conditional statements, right? You can go from P to Q, and then the second premise tells you can go from Q to R, so that means you get from P to R. Another way to look at the hypothetical syllogism is look for a commonality between the antecedent of one conditional and the consequent of another conditional. If you have those, then you have the ingredients for a hypothetical syllogism. And with the conclusion of the hypothetical syllogism, you always bring down, well, I mentioned I don't like the phrase bring down, but here it's very helpful. The left side of the conditional that didn't have the matching part comes down on the left side in the conclusion. So for example, P comes down here, and then the right side in the conclusion is also the right side of one of the premises. In a way, some people say, well, it's like the Q cancels out, and I guess that's true, although it doesn't like disappear or anything. It's not gone. You still get, if you get P, you still get Q too. Yeah, you can just skip it and go to R though. One thing to note about a hypothetical syllogism is that the order of the premises doesn't matter. So for example, if you start with A implies B, and then you have also B implies C, this is an example of hypothetical syllogism. But if you have those same premises, but in the reverse order, so you have B implies C and then A implies B, that's also hypothetical syllogism. In this case, the commonality, the B, which is in between A and C, occurs as the antecedent of the first conditional, and then it's the consequent of the second condition. So it makes a different sort of a visual pattern if you end up looking for that. So that's maybe something to watch out for. Either way, the conclusion is the same. It's A implies C. The next rule of our system is called constructive dilemma, and this one's going to look a little more complicated. It involves more variables when written out. When we actually think about the logical principle that's involved, it's actually a pretty common sense kind of principle. So it's a lot sort of scarier looking than it really is at the end of the day. The first premise is a combination of two conditional statements. It says P implies Q and R implies S. And then the second premise is either P or R. And you'll notice that the either or statement, the two disjuncts on either side of the wedge, are the antecedents of the conditional premise. So if one of those antecedents is true, we can draw the conclusion that one of the consequents has to be true. So we can conclude either Q or S. And like I said, this might look a little intimidating. It's actually really common sense, kind of logical principle, especially if you start with the second premise, the one I listed second at least, the disjunctive premise, either P or R. If one of these two things has to be true, and then if I know what happens in each of those cases, then I know that one of the consequences has to be true. Now our next couple of rules here are, in fact 3 more, are strange, to be honest. They're not argument types that you would typically make if it weren't for the sake of working within a system like this, but they're needed to make our system work. So the first is called simplification. And the simplification rule tells us that if we have as a premise P and Q, P dot Q, then we can draw the conclusion P. And I said the rule was strange, but it's, now that you think about it, it's obviously a valid argument, right? If premise is that we know P and Q, we know both those things, then we draw the conclusion P, it's guaranteed to be true. We already know P and Q. Now, it's not an ordinary kind of argument that you would make. If you had as a premise, if we said, well, at that store they have apples and bananas, you're not going to say, oh, you know what, I just realized that means they have apples. It almost seems redundant, right? But you can see that it is valid. It's always going to be, doing that is always going to be a valid argument. And that kind of argument is needed to make our system work. Remember that goal of creating a complete system where every single conclusion that's valid we can derive. If you have a premise that says A implies B, and another premise tells you both A and C, you need to be able to access the fact that you have A, because it says A and C. Now, strictly speaking, we don't have an instance of modus ponens here, because the antecedent of the first premise is just A by itself. So you need exactly that in order to do modus ponens, in order for that to fit the modus ponens rule here. So that's not quite what you have. You need a rule then that tells you when you have A dot C, A and C, you can write down A. So then you can use that for your left side of your conditional, for your modus ponens. And you're following your rules in a very precise way. Some of these argument forms aren't things that would need to be said in verbal reasoning or reading and writing, reasoning and writing. Nevertheless, they're involved. Part of the exercise is being very precise. It's almost like an exercise in proto-programming or something. So we need a rule like simplification. Our next rule is kind of like the reverse of simplification, called conjunction. And this pertains to the kind of case where you have P as a premise, and the other premise is Q. Now, in other words, that means you just have two premises. P and Q can be anything. So we're just talking about a case where we have two premises. Conjunction rule is going to tell us we can combine those into one premise with dot. So you have P, you have Q, you could say P and Q. So again, this is not the most natural sort of reasoning process. If somebody says to you, they have apples at that store, somebody else says they have bananas at that store, you probably wouldn't say, my God, that means they have apples and bananas. Nevertheless, you can see it's a valid principle, and we need this as a rule for reasons similar to the last one. Now, the next rule is called addition, and this is maybe the strangest of all. Addition tells us when you have a premise that says P, in other words, just any premise, you can conclude either P or Q. And Q also being a variable means Q can be anything. So if you have any premise at all, you can use addition. You can say either that or, and then whatever you want. It's kind of bizarre to imagine using this principle in any other context, but you should be able to see that it's a valid principle. P is already true, so I can say either P or, and anything I want. It's kind of strange if I already know P. Why would I give less specific information? Why would I conclude something less specific? But if I already know, for example, that Popeye likes spinach, I can say either Popeye likes spinach or the moon is made of green cheese, or whatever we want. It doesn't matter, because we already know, but it's already established Popeye likes spinach. Again, it's a strange kind of argument to imagine actually incorporating into speaking or writing. Where this comes in is it's sort of behind the scenes in other inferences, the way the last two rules work. So if we have either A or B, then C, and then we have a second premise that says A, technically speaking, we don't have a case of modus ponens here. In ordinary speech or writing, you might be inclined to just treat this as if it were a case of modus ponens and say, well, if we have A or B, then we get C. So since we have A, that means we're going to get C. But in fact, this doesn't fit the modus ponens form. We have to have, again, exactly the antecedent of our conditional in order to say that we have modus ponens. But since we have a rule like addition, that means we can say, because we have A, we get to say A or B. And then we do have modus ponens because now we have the antecedent of our conditional. So we get to say A or B by virtue of having A, and we have made that explicit by giving ourselves the rule addition. Now, the 8 rules that I've just gone over are called rules of implication, and these are rules that take the shape of a valid argument form. We still don't have a complete system of rules just with the rules of implication. We need another type of rule, which is called a rule of replacement, and I'll be running through those for you in another video.